Hi team, Mr. Vittoria. This is a bridging course for A-level, going from GCSE to A-level Maths, and we're going to continue with section 4. So here we go. Section 4. Solving quadratic equations. Now, when we get something like this, what you expect to solve a quadratic equation is to factorize it, then solve it. So we've done plenty of factorizing quadratics. All we're going to do is try to spot in how to factorize this. Have a look at this 5. First of all, that's singular, so that's just going to be x in each corner. 5 can be split up to 5 and 1, and 5 add 1 will give me 6x. So if I put the plus there, they're both positive. X times x is x squared. X times 5 is 5x. 1 times x is 1x. So 1x plus 5x, 6x. 1 times 5 is 5. So now either this factor can equal 0 or this factor can equal 0. So you can say x plus 1 is equal to 0, in which case x is minus 1. Or you could have x plus 5 can equal 0. The second factor can equal 0, so x will equal minus 5 in this case. So you get two solutions, which are known as the roots, okay, of this equation. Let's go down to the next one. Pause it, have a go, play it, and then check if you're right. Again, looks like a straightforward factorization. 1 and 7 will make 8, and they're both going to be the same. Just plus means they're both going to be the same symbol. So x, and it's only 1x squared, x in each corner. You got the 1 and the 7. In this case, they're both going to be negative, and that's going to equal 0. Double check it. X squared minus 7x minus 1 is minus 8x, and minus 1 times minus 7 plus 7. So either this factor can equal 0, in which case x can equal 1, or you can have this factor equals to 0, in which case x can equal 7. Okay, let's scroll down. So have a quick go at this and then play. Again, very straightforward factorization. This time this is a plus. Again, they're going to be the same, so yes, straightforward. You should think of x in each corner, and I'm thinking 6 and 4 makes 24, and two negatives, minus 4 minus 6 will give me minus 10, and those multiplied together will give me positive 24. So x can equal 6 in this case, and take that as x can equal 4. Okay, so pretty straightforward. Once you know what you're doing, you get the hang of it, and you are expected to do this pretty fluently like this at A level, so get used to it by doing quite a bit of practice. Again, I'm going to put two brackets next to each other, and I'm going to call x in each corner here, so I'm thinking 12 and 3. So 12 and 3 will make 36. Bigger number being positive, smaller being negative. Since plus 12, 12 take away 3 is 9, positive 9, and 12 times minus 3 is minus 36. So x can equal minus 12 in this case. In this case, when will that equal 0? When x is equal to 3. It's always the opposite sign. Let's go into question 5. Now you should be getting the hang of this now. So again, two brackets open next to each other, make that equal to 0, x in each corner. And again, this time I'm thinking 9 and 4. 9 times 4 is 36, but the difference is 5 there. This is going to be a minus, bigger number. This is going to be positive, because minus 9 plus 4 is minus 5, and minus 9 times 4 is minus 36. So x can equal 9, or x can equal minus 4. So you've got the two solutions here. Let's scroll down. Question 6. Again, you should straight away see that 6 times 7 is 42, and the difference is going to be 1. So x in each corner here. 6 and 7. This time the bigger number is going to be positive, smaller going to be negative. So you'll end up with x equals 6. let's just double check this by the way. Minus 6x plus 7x is positive 1x, and minus 6 times 7 is minus 42. So x can be 6, or x can equal minus 7. Okay, let's scroll down here. Now this is a slightly more difficult fraction to factorize, but we're going to stick to our method, what we've done before. So first thing first is to multiply the n numbers together, which is 3 times 3, which gives me 9. Then I'm going to break up 9 into some numbers which will times together to give me 9 and add together to give me 10, so that has to be 1 times 9. I'm breaking 10 into 1x plus 9x, so this stays the same, 3x squared, and this n bit stays the same, 3, but in the middle I'm replacing a positive 10x with plus x plus 9x. This is a positive 3. Okay, once I've done that, I am then going to factorize the first two expressions and the second two, and that equals 0 obviously. So x goes into both of them, and when I'm factorizing I should end up with a common factor of these two, which has been factorized. So this is going to be 3x plus 1, and when I'm factorizing this, 3 is common to both of them, so take the 3 out, positive 3, that's going to be 3x plus 1, and there it is. This factor is common to both of them, so I'm going to take that out, 3x plus 1, and what am I left with is x plus 3. So that is now factorized. Now we're going to solve it. Either this bracket can equal 0 or this can equal 0. So first of all, 3x plus 1 can equal 0. So 3x is equal to minus 1. So x is equal to minus 1 over 3, 1/3. Or you got x plus 3 can equal 0, in which case x would equal minus 3. And that's that. Now, you'll also get something, quadratic equations which you cannot factorize. And there will be, excuse me, there will be a hint given to you where it will tell you to either use your calculator or the quadratic formula. Now, at A level, you will be given you will have the chance to purchase a scientific calculator, which does this on the calculator for you automatically. But it's not difficult, and it's good practice to have a go at this, to doing it yourself, and then later you can go on to doing it on the calculator. But it's always good to practice to try this formula yourself. So first thing first, we need the coefficients. Now if there's no coefficient in front of x squared, then we know there's 1 there. So a equals 1, b equals, don't forget the sign in front, is minus 2, and c equals, again the sign in front, minus 5. So if you plug this into our quadratic formula, you could end up with minus 2, minus minus becomes plus 2, plus or minus, then minus 2 squared is 4, minus 4 times 1 times minus 5, square root all that, all over 2 times 1. So if we simplify this, you'll end up with 2 plus or minus 4. Now 4 times 1 is 4, times minus 5 is minus 20. With the minus there comes a plus 20, all over 2. And if you get the 2 there, plus or minus 24 over 2. Now you can just put this in your calculator and it simplifies everything for you. However, later we'll look at surds, but when you got 24, you can spot, you should look for the biggest square number that goes into 24, which is 4. So it's 4 times 6. And what you can do with surds is you can then go on to split this into root 4 times root 6. And then root 4 obviously is 2. And you end up with 2 root 6. So this will be 2 plus or minus 2 root 6 all over 2. Now when you dividing by 2, you half that and half that, so you end up with 1 plus or minus root 6. Okay, and you can just leave it like that. I mean, you could split it up. I mean, sometimes you might get used to writing it like this, but this is a perfect form. If it does give you two places, your two solutions are, one is 1 plus root 6, and your other solution is 1 minus root 6. Okay, so that's for your two solutions. This combines both of them, and that's simple. So when you square root something, don't forget you get a positive and a negative. That's where your two solutions are coming from. Okay, so again, there's nothing in front, so I'm going to put a 1 there. So A equals 1, B equals 6, C equals 4, and X equals, so minus B is going to be minus 6, plus or minus square root of B squared, which is 36, minus 4 times A, which is 1, times C, which is 4, all over 2 times A, which is 1 in this case. So you'll end up with minus 6 plus or minus 36. 4 times 4 is 16, plus minus 16, all over 2. So you'll end up with minus 6 plus or minus, that's going to be root 20. Again, 20, root 20. You can split that up into 4 times 5, which is the same as root 4, root 5. And root 4 is the same as 2 root 5. So you could replace this with minus 6 plus or minus 2 root 5 all over 2. And if I half minus 6 gives me minus 3. If I half 2 is just 1, so that gives me plus or minus root 5. That is my final answer. Question 10. Again, factorizing this. Well, we can't factorize it, so we're going to use quadratic formulas where A is 1, B is 8, and C is 5. Plug it into our formula. X equals minus B, which is going to be minus 8, plus or minus B squared is 8 squared is 64, and minus 4 times A times C, all square rooted, all over 2 times 1, 2 times 8. So if we get minus 8 plus or minus, we're going to end up with 64, take away 20, square root that, all over 2, which gives me minus 8 plus or minus 44, root 44 over 2. Now again, root 44 can be split into 4 root 4 root 11, which is same as 2 root 11. So I can replace this with minus 8 plus or minus 2 root 11 all over 2, which can be put as minus 4 plus or minus root 11. Okay, now sometimes we given equations like this to solve, and rather than expanding all this and putting it as a quadratic equation, it's much easier way of doing this is just by square rooting both sides first of all. So you end up with x minus 2 equals 36 square root. And remember, when we square root, we get a positive and a negative, so we end up with x minus 2 equals plus or minus 6, and then take the minus 2 to the side by plusing it, so x would equal 2 plus or minus 6. And that's it, we've got two solutions there. Actually, in this case, you're better off writing the two roots that you're going to get. So actually, what you could do here is, that implies x can equal 2 plus 8, which case x is 8, or you can have x equals 2 minus 6, in which case x can equal minus 4. Okay, let's draw that. Again, square root both sides. Now obviously you can't square, well you can square root 5, but you won't get an integer value, so it's best to leave it in series form. So x minus 3 equals 5 root plus or minus, because when you square root you get a positive or a negative, and x can equal 3 plus or minus root 5. And that's the answer. You can just leave it like that, no need to split it up in this form. Okay, question 13. Pause and have a go, otherwise carry on watching. So again, square root. Now 2x plus 1 would equal 3 over 4 square rooted. So square root both sides. Always do the same on both sides, okay? When you're undoing something, inverse the function. Now what you could do here is you could split this up into root 3 over root 4. Now you would have normally a plus and a minus here, but you only have to put the plus and minus at the top on one of them, not on both of them. Now the reason why I split this up, because I've noticed that 4 was a perfect square number, and if I square root 4 it will give me 2, so you end up with plus or minus root 3 at the top all over 2, and you got 2x plus 1. Now you can take the plus 1 to the other side by minusing it, so you end up with 2x equals minus 1 plus or minus root 3 over 2, and then you can take the 2 over by halving everything, so half of minus 1 is minus 1 over 2, plus or minus, and half of half is a quarter, so minus root 3 over 4. You can leave it like this. If you want to put it all over a common denominator, you could double top and bottom here and put it as minus 2 plus or minus 3 all over 4. Okay, right, that's about it. That's our section 4 done.